Welcome to Science. Today we are talking about quantum computing. What is it? Exploring its potential benefits, challenges, and how it may change our world.
Hey everyone, welcome back. Ready for a deep dive into something pretty amazing?
I'm ready.
We're digging into quantum computing today.
Okay.
And more specifically, how it's going to, well, maybe not completely upend,
Yeah,
but really shake up machine learning as we know it.
definitely.
We've got some really interesting research to unpack today.
Right.
A lot of it pulled from Nature Physics, but we're also going to bring in some background from,
Yeah.
Wikipedia and other sources about quantum computing itself,
Yeah, that makes sense.
because not everyone's an expert, right?
Of course.
We'll try to make it clear and exciting for everyone.
For sure.
And just a little teaser, we might even touch on encryption and what this means for the future.
Oh, very cool. Very cool.
So jumping right in, one of the most fascinating things about this Nature Physics article
Yeah.
is that it doesn't just talk about possibilities.
Right.
It actually gives us proof, like solid evidence,
Yeah.
that a quantum computer can be vastly faster
Yes.
than a classical computer,
Yeah.
at least for certain machine learning tasks.
Absolutely. And that's huge. Because for a long time, it's been, theoretical. You
Yeah.
talked about the potential.
The potential, yeah.
But this is really showing it.
It's becoming real.
Yes, exactly.
And what I found really interesting about this specific article is how they actually did it. They used something called quantum kernel methods. And I don't know about you,
Right.
but when I first heard that, I thought, what in the world does that even mean?
It sounds very intimidating.
It does. It sounds like something out of Star Trek, right?
Yeah, exactly.
But essentially, and you can probably explain this way better than I can.
Sure, I'll give it a shot.
They're taking these data points
Yes.
and basically transforming them
Right.
to put them into a quantum feature space.
Yeah.
Which sounds incredibly complex, and it is, but that's where a quantum computer can work its magic.
And to break that down even further, imagine, instead of just looking at data on a flat screen,
Okay.
we're taking that data and almost making it three-dimensional.
Interesting.
So the quantum computer can see all these different angles and relationships that a classical computer just can't grasp.
It's like it's unlocking a whole new dimension of the data.
Exactly. And that's where the speed comes in, because it can analyze these relationships so much faster.
And this isn't just, theoretical mumbo jumbo.
No, not all.
This has real world implications.
Absolutely, and significant ones at that.
Imagine, for example, you're trying to develop a new drug.
Okay.
You've got this massive database of potential candidates, right?
Right.
And you're trying to find the one
Yes.
or the few
Yeah.
that are going to be effective without causing a ton of side effects.
It's a needle in a haystack problem, really.
Exactly. And traditionally, you would have to test each one
Right.
one by one, and it could take years.
Oh, absolutely. Years and years of research and development.
But with these quantum algorithms, you could potentially analyze that entire database much, much faster,
Exponentially faster, in fact.
which means that we could have life-saving treatments available so much sooner.
Exactly. And it's not just limited to medicine.
Right.
Think about finance. Being able to analyze market trends in real time
Oh, wow.
with incredible accuracy could revolutionize how we invest.
Yeah, that would be game-changing.
Or even urban planning.
Yeah.
We could optimize traffic flow in cities.
Oh, that's a good one. No more traffic jams. Sign me up.
Well, that's the dream, isn't it? But seriously, the possibilities are pretty much endless.
It really does feel like we're on the verge of something incredible.
We really are. This is just the tip of the iceberg.
So to really understand this quantum revolution, we need to delve into a bit of the science behind it.
Okay.
We've got to take a trip into the world of quantum mechanics.
Right.
Now, I know that might sound a little intimidating to some people, but trust me, it's fascinating stuff.
Oh, for sure. It's mind-blowing once you start to wrap your head around it.
And it's really not as complicated as it seems, at least for our purposes today.
We'll keep it simple, I promise.
Exactly. We're going to focus on a few key concepts:
Okay.
superposition, entanglement, and quantum tunneling.
Those are the big ones.
Think of it like this. We're about to take a journey into a whole new dimension of reality.
I like that. A new dimension of reality. And it's this dimension that makes quantum computing so powerful.
Okay, so new dimension of reality. Here we come. New dimension of reality. Right. So let's start with this whole superposition thing.
Okay. So
I got to be honest, that one always trips me up a bit.
Yeah, it's kind of a brain twister. It's like, okay, imagine a regular computer bit.
Like a 0 or a 1.
Right, exactly. It can only be one or the other at any given time.
Right. That makes sense.
But a qubit, which is the quantum version of a bit, well, it can be in both states.
Both 0 and 1 at the same time.
Yeah, simultaneously. It's kind of mind-boggling, I know.
So it's not just that we don't know if it's a 0 or a 1 until we measure it.
Right.
It's actually both.
That's the wild part. Think of it like, I don't know.
Okay.
Have you ever seen one of those like novelty coins that has heads on both sides?
So, yeah.
It's not really heads or tails, right? It's just this weird in-between thing.
That's a good analogy. So how does that actually help with computing?
Because it can explore many possibilities at once instead of just one at a time.
Oh, I see.
Like, think of it as a choose-your-own-adventure book.
Okay.
A regular computer has to go down one path at a time. But a quantum computer, it can explore all the different endings simultaneously.
Oh, that's a lot of endings.
Exactly. So you can imagine how that would speed things up.
That's incredible. Okay, so we've got superposition,
Right.
which already sounds like it's straight out of, like, Doctor Strange or something.
Uh-huh. Right.
But then we've got entanglement too, right? Which sounds even weirder if that's even possible.
Yeah, entanglement is a whole other level.
And that's where 2 or more of these qubits are connected.
Yeah, they get all linked together.
Like, how connected are we talking?
Think of it like they're twins separated at birth or something.
Okay.
But even though they're in totally different parts of the world,
Right.
what happens to one instantly affects the other.
Whoa, really? No matter how far apart they are.
Yeah, it's like magic, but it's quantum magic, which is even cooler, in my opinion.
So if you change one qubit, the other one changes too,
Yeah,
even if they're like light years apart.
exactly. And this connection, it allows quantum computers to do calculations in a way that just wouldn't be possible with normal bits.
Because they're all working together.
Exactly. They can share information and coordinate their actions like instantly.
It's like they're a team or something.
Yeah, like a super fast, super coordinated team of quantum superheroes.
Okay, I'm definitely going to need some time to wrap my head around that one. And then on top of all of that, there's quantum tunneling too, which honestly, I don't even know where to begin with that.
All right, so quantum tunneling, it's kind of like,
And I think I read somewhere that this one plays a role in how the qubits actually work.
yeah, it does. It's like,
So it's not just some abstract concept.
no, it's very real and very important.
Okay, I'm all ears.
Imagine, like you throw a tennis ball at a wall.
Okay.
Normally, it's going to bounce right back, right?
Right.
But in the quantum world,
Oh.
that tennis ball, it's got a chance of just going straight through the wall.
What? No way.
I know, it sounds crazy. It's like it can tunnel right through.
It does sound pretty useful for a qubit.
It does, doesn't it? Like I said, it's how they interact, how they share information, even with these barriers in the way.
So, okay, I think I'm starting to get it. We have these 3 incredible phenomena.
Right.
Superposition, entanglement, and this quantum tunneling.
Yeah.
And they all work together to make quantum computing possible.
Exactly. They're like the fundamental ingredients.
The secret sauce. So we've got this incredible power,
We do.
but it can't all be smooth sailing, right?
Well, every superhero has their weakness, right?
So we've got all this power, all this potential, but what does it actually mean for the future? Like, what are we going to do with all of this?
Well, that's the really exciting part
Yeah.
because the possibilities are almost limitless. It's like, imagine a world where instead of just finding new materials, we can actually design them from scratch.
Oh, wow. Really? Like atom by atom.
Exactly. We could create materials with properties we've never even dreamt of.
So we could have like super efficient solar panels.
Right. Or batteries that last for weeks.
Or even like flying cars. Is that too much?
Hey, I wouldn't rule anything out. The point is, we're talking about a whole new era of materials science.
That's incredible. And I know we've talked about medicine a bit already.
Right.
But it feels like this could really be revolutionary for healthcare, right?
Oh, absolutely. I mean, imagine being able to simulate complex biological processes
Okay.
at a level of detail that's just impossible right now.
So we can understand how diseases work at a much deeper level.
Exactly. And then design drugs that just get them with incredible precision.
So less side effects, faster development times.
Yes, exactly. And potentially even cures for diseases that are currently considered incurable.
Wow. It feels like
It's a game changer.
it really does. It's like we're about to unlock a whole new level of understanding about ourselves and the world around us.
And here's the thing. We've only just scratched the surface of what's possible with quantum computing.
There's so much more to come.
Oh, absolutely. Every day, researchers are making new breakthroughs,
Wow.
pushing the boundaries of what we thought was possible.
It's kind of mind-blowing when you think about it.
It really is. And it's important to remember this isn't just science fiction anymore.
Right.
This is happening right now.
It's real.
Yeah, quantum computers are becoming more powerful,
Yeah.
more accessible.
That's a good thing.
And the applications are only going to get more amazing in the years to come.
So it sounds like we should all be paying attention to this,
Oh, for sure.
even if we don't fully understand the ins and outs of how it all works.
Right. Even if you don't know a quibbit from a coffee mug, you should still be excited about this stuff.
Because it's going to impact all of our lives.
Exactly. And who knows, maybe one of our listeners today will be the one to make the next big breakthrough in quantum computing.
That would be incredible. Well, on that note, I think we've given our listeners a lot to think about.
I hope so. It's fascinating stuff.
It really is. So until next time, keep exploring, keep asking questions, and most importantly, keep that curiosity alive.
We hope you enjoyed this episode of Welcome to Science. Welcome To is dedicated to exploring new technology to create informative and entertaining media. If you would like to create a podcast like this, be sure to visit Google Notebook LM. If you enjoyed this episode, please be sure to like and subscribe for more. Leave a comment if you have an idea for an episode that we should start researching. Thank you for listening.